Okay, welcome to Kinematic Practice number 2. We're going to look at the remaining part of your homework. If you look here, it says a plane cruising at 250 meters per second accelerates at 27 meters per second for 7.1 seconds. It wants to know final velocity. Remember that there's two equations that you could use for final velocity. In this case, because you have time, you're going to use VF is equal to VI plus AT. In this case, your final velocity is what you're solving for. You had an initial velocity of 245 meters per second. And we're going to add to that, it accelerated 27 meters second squared. And the time it did that for was 7.1 seconds. So when you go ahead and solve for that final velocity, and we'll put those in your calculator, you should come out to 436.7 meters per second. Remember, it's a final velocity, it needs to be meters per second. Now the next question on that, it's a part 2, says how far will it have traveled? Okay. Well, now you've got some data. We're trying to solve for XF. We need to know what was its initial position, what was its original velocity times the time that it traveled, and then we're also going to have to add in 1/2 of the acceleration times the time squared. Okay, so using the value that we've gotten from the values that we've gotten from up here in the equation, we can note that there was no initial displacement, so we can leave that out of the equation, and we get the initial velocity of 245 meters per second times the time seconds plus 1/2 of the acceleration, which was 27 meters per second squared, times the time of 7.1 seconds, and then we're going to square that. So plugging that into my calculator, I will get this value. Okay, you could also rewrite that as 2,400 meters. All right. Next, we're going to move on to our next layer, which is Air Jordan. Move on to it real quick. In this question, you see that hold on, let me erase my marking there. That may not let me. All right, so in this question, you see that a basketball player achieves a hang time of 0.82 seconds. So we have a time, and it wants to know the vertical height obtained. That's going to be an XF equation. The acceleration of gravity is 9.8. All right, so real quick, let's throw that back over here to the side. Let's make some notes of things that we have. We know that the time is equal to 0.82 seconds. We also know that acceleration due to gravity is 9.8 meters per second squared. We are going to try to think about this in terms of him going up and down, not horizontal. We're not going to worry about that component. We want to start with an initial velocity of 0 and initial position of 0. So we'll call that at the very peak height. What was he? So that means the entire time that it took him to go this distance was 0.82. Okay, so we need to divide that by 2. So take 0.82, divide by 2, and you should get the actual t, which will mark that out. The actual t should be 0.41 for his descent, and that's what we're going to focus on. So for the XF equation, if we have a 0 position and a 0 velocity, that leaves with 1/2 AT squared. All right, so then we go ahead and plug that in, and we get 1/2 9.8 meters per second squared times 0.41 seconds squared. All right. And then that gives us an xf, or the height that he would have traveled, of Alright, there you go. Let's move on to the... Alright, this last problem says you are trying to find out how high you have to pitch a water balloon in order to burst it when it hits the ground. You discover that the balloon burst when you have pitched it to a height of 19 meters. With what velocity did the balloon hit the ground? The acceleration to gravity is this. Okay, so we were solving for the final velocity here. So real quick, let's put that over here to the side. We have a final velocity. Notice we have no time, and we have no initial velocity if we start at the peak height. We just have a displacement. So what we're going to use the equation Vf squared is equal to Vi squared plus... Okay, so I'm sorry I had to pause it and read back. I made a little mistake. So we got Vi squared and then 2a xf minus xi. Alright, so now when we go to look at this, we're going to say we want to know what the final velocity. We know that if we started at the peak height, you threw the balloon up in the air, it stops and comes back down. Your initial velocity was 0, so this guy goes away. And you're going to have 2 times 9.8 meters per second squared times, we know the difference here is going to be 19, and that's of course a negative, and then we have a negative 19 meters. Okay, so we're going to multiply those two things together. So fill that out real quick. Vf squared is equal to 2 times 9.8 and times negative 19. So we should get a 372.4. But we're not done. We have to take the square root of that and the square root of that, and that's going to give you a final velocity in meters per second of 19.30 meters per second. All right, hopefully that helped you out with your homework. If you have any questions, please let me know. Okay, and remember, when you take a square root of anything, it's really plus or minus. Okay, so in this case, because we know the object is dropping, we're going to call that a negative velocity. So it would be negative instead of the plus. So when you submit your answer, make sure you put in a negative sign.